For this episode, we're going to discuss linear versus switching DC to DC power conversion. Power conversion is a process of converting AC to DC, shifting voltage levels, changing frequency, or a combination of these. In electronics, power conversion is necessary to provide the appropriate power required by each of the electronic devices within a system. A power converter, also known as a power supply, can either be linear or switch mode. Linear power supplies use linear regulators that implement non-switching methods. In order to regulate the output voltage, all linear regulators specify a dropout voltage, which should be the smallest difference between the input voltage and the expected output voltage. For switch mode power supplies, most of them use switching regulators to regulate the output voltage. By turning the switching devices on and off, the regulator dissipates almost no power, which makes it very efficient. Linear power supplies, which utilize linear regulators, are practical for low power applications. They are simple to use, inexpensive, and less noisy electrically. However, for high power applications, they dissipate more power, which makes them inefficient, typically around 50%. Switch mode power supplies are a better option for applications that require high efficiency, design flexibility, and a wide input voltage range. Switching regulators can achieve over 90% efficiency. Though switching regulators have many advantages over linear regulators, they are complicated to design, which typically makes them more expensive, and the switching generates output ripple and EMI. Let's take a look at both types of regulators. Here I have two evaluation boards from DFRobot. This one, which is model number DFR0140, consists of two low dropout linear regulators, while this one, model number DFRO205, has an onboard buck DC to DC converter. The power supply will be used as the input voltage for the evaluation boards, while the multimeter will be used to measure the output voltage. We will also take a look at the noise of the output voltages using an oscilloscope. Now, let's try to examine and compare these two boards. This is a schematic of the evaluation board that contains the linear regulators. As you can see, the design is just simple. It has a 3.3 volt and a 5 volt linear regulator that uses only one capacitor each for its input and output. Now, let's turn on the power supply. Then I'll turn on the eval board. And the DMM shows us 4.99 volts. It's actually 5 volts. Maybe the DMM just needs to be calibrated a bit, but we're looking at 5 volts there. And these regulators, obviously they're very easy to use, and they only require a 1.15 volt dropout voltage. However, they can only provide the load a maximum of 500 milliamps. And as a difference between the input and output voltage increases, their efficiency decreases. We'll now connect the oscilloscope to the 5 volt output voltage. And I'll turn it on. Again, we see that the output voltage is at 5 volts, but take note that there is no discernible voltage noise. Now, let's take a look at the evaluation board for the switching regulator. So as you can see in its schematic, the design for the switching regulator is more complicated than the linear regulator. It uses external components that would require a lot of computations to select the right value and rating. But the benefit is the switching regulator can deliver 25 watts of power to its load and can operate from a 3.6 volt to 25 volt input voltage. So for this evaluation board, the first thing we need to do is move the switch over to 5 volts. With that done, I'll go ahead and connect the power supply. And then we see 5 volts on the DMM. Obviously it's 5.01, but maybe the DMM just needs to be calibrated, but we're connected to the 5 volt output on that evaluation board. With this particular eval board, again, we get an output of up to 25 watts, so it can supply the load at 5 volts up to 5 amps. So using the oscilloscope, again, we see 5 volts, but we also see quite a bit of switching noise on the output voltage. I hope you enjoyed this video from Digi-Key. Thanks for watching.